Moved on to, so those were Mendelian. From there, we moved on to sex-linked traits. Sex-linked traits are non-Mendelian. In other words, they don't follow the simple rules of tall, short that we saw, right? We noticed that it got more complicated. Suddenly we had to stop and think about all of the potential genotypes before we made our Punnett squares. Another common form of non-Mendelian inheritance there are two kinds. One that we call incomplete dominance. One that we call codominance. And one that we call multiple alleles. So when we looked at Mendelian traits like tall, we realized there are two alleles. There's a tall allele and there's a short allele. And if you inherited one tall allele and one short allele, then you were still tall. Sometimes people want to make that offspring who is one tall, one short, they want to make them medium height. But in Mendelian inheritance, that's not how it works. You have one that's dominant and one that's recessive. In incomplete dominance, so the first one, we have two different choices for alleles still. So there are two alleles, but neither one is dominant. Or recessive. What that means is traits end up blending in that weird way that we said that they didn't in Mendelian inheritance. Classic examples of this kind of inheritance happen in flowers all the time, like the 4 o'clock or a snapdragon. The two choices for alleles are capital R for red or capital W for white. If a snapdragon has a red flower, that means that it inherited two red alleles. So if it has a red flower, it inherited two red alleles. If it has a white flower, it inherited two white alleles. So the genotypes and the phenotypes are red or white. But something strange happens when you mate a red parent with a white parent. So if you take a red flower and pollinate it with a white flower, you do not end up with red or white offspring. The genotype RW corresponds to the phenotype pink. So we see a blending of traits. So traits blend. That only happens in the instance of incomplete dominance. So it's not common and is most common among usually plants, particularly for color. So we end up with pink. The second option I gave you was codominance. Here you have the same situation. You have two alleles where neither is dominant, and neither is recessive. But instead of blending traits, both traits appear. One of the most popular biological examples of this is among chickens. Chickens come in a variety of colors, right? You guys have seen, presumably, chickens before? No? Yes? Color of the chicken's ear depends on the color of egg it's going to lay, all that. Yeah, chickens have ears underneath their feathers, so. No, they're like little holes in the sides of their head. They have little holes in the sides of their head, and those holes have colors. And if they are a red-eared chicken, they lay brown chicken eggs, which is why there's brown eggs. And if they are white-eared chickens, they lay white eggs. There are some chickens whose ears have a blue tinge to them, so their eggs are blue. So if you've ever seen eggs, like farm fresh eggs, and you're like, why are they so many different colors? It's because of the color of ear the chicken has. That's all that is. So there's all kinds of crazy traits in chickens like that, whether or not their legs have feathers on them versus legs that don't have feathers on them. So they're like naked legs, and some of them, some chickens, the ones with feathers on them, look like they're wearing like a pair of pants, little feather pants all the way down to their ankles. That's how they predict it. Somehow genetically they're related to the pigments that they make. I would assume, my guess, is that the pigment that's made in their cartilage that would compose the ear hole would be similar to the compound that makes up the eggshell. And thus they would both have the same color.
One time there was a brown-eared chicken and it lays a white egg.
It won't. It can't. No matter how hard it tries. It will never lay a white egg. If it pushes so hard, it's just going to make more eggs.
White and brown egg, like I think brown has like more protein in it, and that's what like got more like heart health. Is it because of the color?
Statistically, there's not actually a significant difference between the two. What actually influences it more often is the age of the egg. Brown eggs tend to be, for the purposes of what makes it to market, they tend to be fresher. The fresher the egg, the higher the nutrition value is in the egg, and the better the egg tastes. Eggs that come out of a chicken that you eat that day taste significantly better than eggs that are old. Most people just haven't had fresh chicken eggs to know the difference. Weirdly though, chickens, in all their different chicken varieties, there are chickens, or there's an allele in chicken that controls their feather color. They can either have black feathers, and that will make a black chicken. They can have white feathers. Yep. And if you mate a chicken that has black feathers with a chicken that has white feathers, if it were incompletely dominant, they would make a gray chicken. But in this instance, it's not incomplete dominance. Instead, you end up with a black and white chicken. It's speckled. Some of its feathers are black, some of its feathers are white. It is like a Dalmatian chicken.
So that's why they have like chicken breeding and stuff?
Mm-hmm. There are all different kinds of chickens. All of the chickens produce different size eggs at different frequencies. So there are farmers who work very hard at breeding chickens for specific traits. That's what they do. It's actually fairly interesting. That's the difference between incomplete dominance and codominance. Incomplete traits blend. Codominance means you will see both traits. So if you have a black allele and a white allele, you will see black and you will see white. You will not see a blend of those. You won't see gray. As opposed to our flowers that we were talking about that are incomplete dominance, you don't see a red and white spotted flower. Instead, you see a pink flower. So that's incomplete versus codominance. Those two are actually a lot easier to do as far as Punnett squares go, because there's only so many possibilities. Those are much easier to do. Multiple alleles we will do together on Friday after your quiz. It will be significantly trickier, but I'm confident you'll be able to do it. This is where I want to take the opportunity, guys. I know you're not going to be here tomorrow because you're going to be out in Pledge Faith in Action. Have you been told where you're going?
No.